All right, there we go. Now we're live streaming, so I'm going to go ahead and start recording. Hello, everyone, and welcome to the next session of Zymposium on building better open source. Returning to Zymposium after probably what, 2-3 months is Nabil,
Yeah,
Zio
something about
contributor
that.
and one of the leads of development on the open source project Zio HTTP. So, Nabil, please share just a few words about your background with the audience today.
Yeah, so I'm basically a Scala developer all my professional life, which is not yet 10 years, but almost. And I came to know Zio some years ago and really liked it. And after having some workshops with John and joining some conferences, I also became uh, a contributor to Zio libraries and especially to Zio HTTP. And yeah, besides that, at my day job, I work for Rewe Digital. That's a company in Germany. We do for the big grocery retailer Rewe here in Germany, the online shop and grocery deliveries.
Well, good to have you on board, Nabil, and good to have you back. And
Yeah.
today we're going to be taking a look at how we can add support for parsing Smithy to Zio HTTP. Is that correct?
Yes. So we want to have like a first level support for Smithy in the HTTP. So you can define Smithy specs and generate the HTTP endpoints out of it. So we have like some high level endpoint API. If you come from a Scala background, but you don't know the HTTP yet, Tapir basically is the same idea. I don't actually know any other programming language that has this kind of declarative endpoint definitions. Um, I mean, I also don't know all the programming languages out there, right? But I know
Sure.
some Java, some Kotlin, some I don't know, and I didn't see something like that before. But the basic idea is you describe your endpoint first, and then you can either implement a server or a client based on this endpoint definition.
So,
And
just for those audience members who are maybe not familiar with Smithy, what would be your elevator pitch for Smithy?
yeah, so the basic idea, I guess, behind Smithy is in a world where the uh, big companies have a lot of teams that work with many different languages. They want to be able to define APIs in a language and protocol agnostic way, so that you only say, okay, I want to have something that takes this as an input, gives this as an output, and it's just a high level definition. And then what you can do is you can say like, okay, I want to have this uh, with a protocol that is transporting this information. That can be a REST endpoint or gRPC or something like that. And then you generate out of Smithy your language specific, I don't know, Java, Scala, Kotlin, Ruby,
Yeah.
whatever you want.
So basically, we might
Right.
say that like Open API allows you to describe your HTTP API in a
Yes,
language agnostic way that allows you to like generate clients and validators and all that other stuff. Really great tooling.
exactly.
But if you want to go in a protocol agnostic way, you need something higher level than Open API. And so you might grab
Yes.
Smithy off the shelf. And Smithy not only gets you the sort of language agnostic nature of OpenAPI, but also it's protocol agnostic. So you can say, well, I want gRPC and Rust, or I want Scala and REST API, or whatever you want.
Yeah. Of course, then at the end, you need to, when you have two services talking with each other, uh, talks the same thing, right? You cannot
Yes,
have one talking REST, the other gRPC. That will not work.
yes,
But yeah, at least you have some very high level thing. And at the end, this is also something we do with the HTTP. You might offer um, two protocols for the same data.
yeah, that's right. All right, so what we're going to be doing today is we're going to look at how we can parse Smithy with the end goal of generating ZO HTTP endpoint definitions. So basically
Yes.
a way to go from Smithy specs to typed Scala code that then a developer can come along and insert their typed implementation of the different endpoints in some sort of API. Is that correct?
Yeah, kind of. So we have already like generation capabilities for OpenAPI and gRPC in Zero
Yeah,
HTTP, and we have some intermediate formats that we use to actually generate the endpoints.
yeah,
So our main goal should be that we can read Smithy into some Scala data structure that then can be transformed to this
into the
intermediate
intermediate.
exactly
Yeah,
so we can generate the code.
makes
So
sense. Okay,
yeah, and
so I think for many people who are joining us today on the live stream or watching the video, they'll this might be their first introduction to parsing something because ordinarily developers use parsing libraries. They already have JSON parsing libraries, XML parsing
yes,
libraries, HTML parsing libraries. So here, what we're trying to do is parse something, take its text format, and turn it into a data structure that's easier to work with. So that parsing is perhaps not an everyday occurrence for the typical software developer. This might be a new experience for folks. But I think fundamentally, even if you have never written a parser, you are benefiting from it in your day-to-day programming via whatever JSON libraries you use or REST APIs, or even sort of if you want to consider binary codecs a form of parsing, use gRPC or anything, you are using parsers implicitly. Now, in this case, we're thinking about building a parser into Zio HTTP, probably because there is no standalone Scala library that parses Smithy, I assume. Probably no just clean, no dependency
yeah,
library that,
I also don't think so. So there is like Smithy for S, but it does like all the Smithy things uh, very tightly to HTTP for S, and there is like
right.
I didn't see that there is like a single library just for parsing.
Okay, all right. So we'll take a crack at this. And in general, the way things work in the world of parsing is that the syntax for your language or your format, Smithy format, JSON, whatever, is defined by something called a grammar. And that
Yes.
grammar dictates basically the set of valid text files that can be parsed by that grammar. And you can use that grammar to build a parser. And the parser's job is to actually read through a given text file and convert it into more structured information, or tell you that there's some syntax error, that it basically violates the spec and that it can't be parsed. So the first thing we're going to need, why don't you go ahead and share your screen, pull up Zio HTTP so we can get to work on this. I think the first thing
Yeah.
we're going to need is a grammar for Smithy that describes formally what it means for something to be a valid Smithy file.
Let me just see. Oh, I think I might have an issue. Uh, yeah, I think I have to rejoin because I didn't give Zoom
Permissions.
permissions. Exactly.
All right.
I'll be
Well,
back
I'll
in a
see you in a minute or two. So typically, grammars are specified in Bauer-Nakas form, which is this way of describing how to generate a text file that will conform to the grammar. And we'll see examples of that. The IDL for Smithy is defined in a sort of extended or augmented BNF notation that it has a few support for, I think, regexes and a few other things in there, just to make it more easy to compactly define the Smithy IDL.
So
Okay, so I see a spec here with maybe
yeah,
some failing test cases.
yes, something like that. And I also have some data structure that basically represents Smithy roughly. Probably there's a few things that we need to add or maybe change the structure a little bit.
Okay.
But as we were talking about grammars, so in the
Yes.
official Smithy documentation, there is this ABNF for the Smithy IDL.
Yeah,
And I guess that's what we will be mainly working with today.
that's right. And the way to interpret this, by the way, is like let's take the IDL line. So the IDL line basically describes what would be called a non-terminal production in the grammar, and IDL is defined to be equal to, and then the spaces there are basically concatenation. So we use this grammar to define valid text files. Text files are linear, and so the spaces here represent we're going to have this thing first, and this thing second, and this thing third, and this thing fourth. And you can see there the very first thing is this thing called WS. WS is a standard name for a white space, basically. It's defined down there below, but basically it says some number of white space characters followed by a control section, followed by a metadata section, followed by a shape section. And then each one of those different terminals or non-terminals in the grammar are defined below. And together, all of these definitions define precisely which text files conform to the grammar and which do not. So it looks like, Nabil, you've already gone through and created a data structure which can hold the
Yes.
typed information. So our
At,
job,
at, at least the things that were most important, that were most dominant in the documentation, I put already in. But as I said, probably we need to add a few things here or there or change them.
yeah, okay,
So I'm also not a Smithy expert, like
yes, I'm
I,
not either.
yeah, yeah.
Okay, so let's see here. I think, are you using Copilot or other AI assistance
Yes,
tool?
I have Copilot.
Then let's copy paste this entire grammar into a comment in the Scala file, just so we can get some AI assistance. Yeah,
Yeah,
perfect. Okay.
wonderful.
And now, do you want me to, should we check this Smithy ADT or do you think it's good to go for now?
I think I would start with it, and when we find something that is not matching, then we
Sounds
adjust
good.
on the fly.
All right. So we don't really want to be parsing this by writing a parser manually and going through every single character in the input string and trying to figure out what corresponding structure to use. What we really want is to use some sort of parser library that can help us build out a parser for Smithy in a shorter amount of time. So, Nabil, I think we talked about two possibilities for this,
Yes.
either trying Zio parsing or maybe try to use one of the parsers that's built into Zio HTTP. Do you have a preference there
Yeah.
regarding
I,
which path we go?
I think if we can make it work at the end with the rich text codecs, the one that is in the HTTP, it might be easier for maintenance purposes
Yes.
because we don't need to fix something in another library if something is broken or something like
Yes.
that.
Right.
I would start with it and see if we can work with it. I would
Yeah.
prefer it.
All right. So rich text codec is a parser of sorts that's built into Zio HTTP. And rich text codec, what it allows you to do is not only parse some text information into some structured form, but also to turn that structured form back into the original text. And that act of turning the structured information into the unstructured text is known as printing or pretty printing or rendering. So typically when you build a parser, you also build a printer because it's very handy to be able to parse something into the structured form, do some manipulations, and then to turn it back into its text form. Like every code formatter does that. When you format your code, that information is parsed into structured form, and then it's turned back into the unstructured information using a pretty printer. So using rich text codec will give us the ability to not only parse Smithy into some sort of type data structure, but also to turn that type data structure back into its original text. Now, that said, there are some, I would say, inconveniences that one encounters when one tries to describe the structure of Smithy or whatever using a so-called invertible parser. That is a parser that can go from text to structured form and structured form back into text. It's more cumbersome. You have to hold on to more information in the act of parsing. And this data structure that you designed, Nabil, probably does not store white space now. So we have to
No,
just decide if we want to extend this in such a fashion that it can store white space, or if we want to change this so that when you parse it to structured and you go back to unstructured, it might not look exactly the same as it started.
I would prefer the second one because this
Okay,
data structure, we don't actually need the white space information for our endpoint generation. And I think
sure.
it's okay to have like some standard formats that we put directly into the parser logic.
Yeah. All right, that makes sense. All right, so let's start with white space. Right? Let's look at the first thing inside here in the grammar. The starting point or entry point to the grammar is the white space. Can you show me that again? Maybe split the window so we don't have to keep on going back and forth.
Yeah, I can do that. Uh,
Perfect. Okay,
yeah,
so we have white space, and white space is defined as one
space.
space character or new line or comment or comma.
Yeah,
Okay, so we're going to have to define, yeah, white space as one thing or another thing or another thing or another thing. So let's go ahead and see what rich text codec already has. What sort of constructors does it have for us? It does have white space char, but I don't think that's exactly what we need. I think
there's white
I think what I would like,
spaces.
first off, can you look at the alternation in rich text codec? We need some disjunction. We need a way to say that one term is really a composite of this or this or this other term. So,
This one.
okay, yes. So this is the pipe operator. And this bit, when you use it on two rich text codecs and you say that A is either B or C, then it means that A is defined as either a B production or a C production, and that's ordered choice. So it's always going to prefer the first one if that one is going to succeed. So what we're actually building here is a recognizer, not exactly a parser. And there's some hand wavy stuff that we're going to have to skip over for now, involved in how we're justified in using a recognizer to, or rather, basing our recognizer on the A, B, and F grammar. But we're going to try to do it in such a way that the resulting parser ends up being faithful to the underlying grammar. But I won't go into all the details now. All right, so we have this alternation, and this alternation says that we can combine a rich text codec of A and a rich text codec of B into another rich text codec of either A, B by using this fallback semantic.
Yeah.
So let's go back to our parser that we're defining inside of here. And let's literally write down White space is defined to be SP or NL or comment or comma. And then we're going to define each one of those separately down below.
Okay.
And maybe make these lazy vowels because I don't want to really care
Yeah,
about
yeah.
the order. The difference between a vowel and lazy vowel is just order of initialization is ordinarily in Scala top to bottom. But if they're lazy vowels, then you can get around that limitation. Perfect. And then now we need to define space, right? We need to define space as, and I think that space is defined as, space is defined as one or more spaces. Okay, so we've got one other piece of information here, which is it looks like this notation one times means one or more. I
Yeah.
thought it meant one, but this is A, B, and F, which I'm not super familiar with. It looks like to me here that that actually means one or more. So what that means is we need to see if rich text codec has an operator that means one or more.
And
Can
by
you
the way,
maybe
also this brackets here is probably means it's
it's a
optional,
list,
right?
right? Oh, optional. Yes, that's right. Optional.
Yeah, because it's already
So an
more than one.
optional, yes. So that means optional white space and the one times must mean at least once.
Yeah.
Okay, so let's go back to rich text codec and look for a method that will give us one or more of something. Because this grammar is telling us we need to be able to find one or more of these things in the text file. So look through all the methods of rich text codec. It would not be, most likely not be a constructor. It would actually be a
I,
method on an existing.
yeah. So probably we just use a constructor to construct like a single white space first.
Sure, sure, why not? So do
So
char, and it says, what is that? Percentage X, so hexadecimal 20 or 9. What are those?
20 is a space, and I
Oh,
think
or tab.
9 is
Okay.
tab. Yeah.
Okay, so is there a char, like multiple chars?
Yeah, there's also chars.
Okay, do that one and do white space or tab. Okay. And Copilot does not yet know
No,
which method exists. So let's look for a repetition method that guarantees at least one thing.
this one.
That might work, but I think that's 0 or more.
Yeah,
Can you go to the definition of that?
sure.
Yeah, see, this is 0 or more.
What is this here? Singleton, which returns a non-empty chunk.
That does return a non-empty chunk, which makes me think that it's non-empty, but it's called singleton, and I
Yeah,
see there, yeah,
it's
so
probably
it's
it's only one, right? Yeah.
it's only one. Yeah, so what we really need is
Yeah, but it's the only non-empty.
repeat non-empty. So let's go ahead and add one
Yeah.
right next to repeat. Let's just add another one here, which would be a final lazy val repeat non-empty maybe. And what this operator will do is return a non-empty chunk of whatever the original parser would have returned, taking care to fail in the
Yeah.
event that it's empty. And what do we need to do here? We need to call try that. That looks roughly correct. We need to call transformer
Yeah.
fail, but actually I think we only need to fail in one way, right? So we could probably use um, one of these variations.
Transform or fail left or something like this, you mean?
Yeah. Oh, well, no. Yeah, I think that's right. Yeah. Transformer fail left. And then if the chunk is empty, we fail. So what we're doing here is we're taking an existing operator, which is repeat, and we're trying to basically produce using transform another rich text codec that will fail if that chunk happens to be empty. So if it's going to parse, the original repeat will accept 0 repetitions as being valid. We want to prevent that from happening, which means we want at least one thing in that chunk. Otherwise, we're going to fail. Yeah. Although, does non-empty chunk have such a constructor? Oh, yeah, that's valid, right?
Right?
That's valid. Yeah. Okay. And then we just convert the chunk to chunk. Okay. That looks good to me. All right. So repeat non-empty will now, if you call it on an existing rich text codec, it's going to give you a new rich text codec that will parse at least one of those things. So now we can go back to our parser in progress, and we can make, yes, repeat non-empty here. Perfect.
Yes.
So now we're saying we want at least one, either space or tab character, which is exactly what the grammar on the left-hand side says. Okay, but let's look at the type of this. What is the inferred type of SP?
It's a non-empty or a text codec of non-empty chunk of char.
Yeah, that's not a fun type. So,
Also, we actually don't need the output, right?
yeah, so what I want to do is sort of map this away to, there is no map on, but there is a unit, right? Or what is there? Is there a
As
unit on there? Is that unit basically?
I think it's like map it to whatever you want, right? So I can probably
But
just
is
do
there
this.
implicit evidence? Oh no, that's requiring that we first transform it to be unit, right? Yeah, that
Yes.
requires that A be a unit. So what we're going to do here is we first need to, is there another method that might allow us to do this?
Transform.
That can work, right? Because we can transform to unit. So what we do is we call transform, and we've got to go from a non-empty, basically we're trying to change the type of value that is produced by this rich text codec, but it's slightly complicated because not only do rich text codecs, not only do they produce values, but they also consume them. Because they can go from text to structured and from structured to text. So instead of just mapping over a rich text codec, we actually have to go both ways. We have to map to and map from, which means we need to supply two functions. So what we're going to do here, what Nabil or Copilot has already done, is basically say we want to go from a non-empty chunk um, of a character into the unit value. And also we want to go from a unit value into a non-empty chunk. So put that char inside a non-empty chunk.
Yeah, of course. That was what I was
And
missing.
basically what we're saying here is when we parse a bunch of white space into structured representation, if we take that structured information and go back to text, we're going to get a single white space. In other words, this is a lossy transformation. So we're throwing away
Yes.
information on white space, which is what we said we were going to do. And it makes this simpler. Right? It makes it simpler if we don't have to
Yeah.
keep track of how many white space characters and what they were. But that is essentially what we're doing, is throwing away information. So if you use this rich text codec to parse the Smithy and go back, you're going to get back a different Smithy than the one you started with in general. But it's going to parse the same because we ignore white space. White space is for humans, not machines. The Smithy will mean the same thing, even if it doesn't look the same way. All right,
And
so now we have space.
and what we also do, so when we actually generate the endpoint code, we do the same thing. We also just like we have just like the necessary white space that doesn't change the meaning, right? So you cannot
Yes,
put like two identifiers together without a white space, then it's a
that's right.
problem. Um, and then we just use Scala FMT, the formatter for Scala, to format it in a nice way, and you can hand over a configuration. Um, I would expect, since there are also IDE plugins and stuff like this for Smithy, that there is somewhere out there a Smithy
Probably.
formatter that we could use later on to format it in a
Yeah,
nice way if we wanted to.
sure. Okay, so we've done space. Let's do new line. And can you open up the left-hand side so we can see what new line is defined as?
I I think it's probably pretty similar to this.
Okay, so
So
it is either
it's
backslash n or it is the combination of backslash
RN.
r and backslash n.
Yes.
So here we're going to use maybe a slightly different. It's going to be no, that's not going to be correct. We need it to be backslash n. So you need a char, just a
Yeah.
single char, which would be backslash n, or you need, I don't know, is there like a literal? Like, is there which you need or the or symbol here? Is there a char
Uh,
literal?
uh,
There's not. There's
but
string.
this is a char literal or not? Like
Okay, well,
this.
do char. But there's no like. I'm trying to get at. I want to parse two things, like two characters, right? I would suspect there's already a constructor inside here that will do that. So can you go to rich text codec, the object, and see if there's a constructor that accepts a string? Ordinarily, this would be called literal.
Ah, yeah,
This
there
is it,
is.
right? Yeah,
Yeah.
okay. So let's do that, literal, and we pass it backslash r backslash n. Oop, yeah. And then we transform same as before. And what are we going to transform this to? Is this empty?
I think first of all we
Let's
have
see. Is
to do this. Oops.
Oh, the non-empty is actually not at the level. No, no, SP is okay. So here for new line, it's saying there's a single new line, right?
Yes,
If
a
I'm
single.
reading the grammar right, it's saying
Yeah,
there's a single new line. Okay, so this is correct, right? So you just need to
this one here is not so. We need to
turn it
give
into
back.
backslash n. Yeah, a left of it needs to be a left, right? Because we have an either. The
Uh,
result of the or is
what is actually the type that
it's an
comes back?
either.
But
It's an either of
yeah,
it's an
yeah,
either of character or string. So what we need to do
yes,
here is return a left of a backslash n, or you could do a right of backslash r backslash n. This has to be a character, not a string.
yeah.
Okay. So now we're saying we're going to parse a new line into this structured information, but we're always going to take that structured information and turn it back to backslash n, even if what we parsed was backslash r backslash n. So again, we're throwing away some information as we define this invertible parser here. And now we have a comment, which is going to be, what is a comment defined as? Or comma, not comment. Oh, comment is next.
Comments
So what is
first.
comment?
Yes. A comment is a documentation comment or a line comment.
All right.
And a documentation comment is triple slash and a line comment two
Okay. Well,
slashes.
let's accept Copilot's auto completion for this because why not?
Yeah, let's see how far we can go.
Um, and then, whoa, what happened here?
It
So
says it wants not a new line.
not a new line. So zero or more not a new lines, followed by a new
First
line.
character slash slash can't be slash sync. Yeah.
So what is that inside parentheses there?
So this is tab, I guess, right? Was it not?
Dab
Yes.
and not new line is a range. So that's a range there from 20 to 2E, whatever that is. Ah, that's not fun.
Not so much.
We don't have an easy way to specify these ranges.
You can.
Maybe we could use filter. There's a filter on rich text codec that we could potentially use for this. So what is this saying? It's saying a literal, which would be, wait a minute, is this documentation comment? I can't see them both. Is
So
it
so
possible
this
to vertically split it?
uh, probably,
Perfect.
yeah. I think that makes more sense. Where are we here? Yeah. So
Yeah.
documentation comment is actually easier, right? So it's just triple slash,
Three.
not a new line and a new line. So something, any kind of character that is not a new line, right? And it
Yeah.
ends with a new line.
Okay. And right now it's using these right, right fish and left fish operators there, which I don't know if they actually exist. Can
I
you check?
think maybe it's, yeah, that one exists with it's tilde. I think that's the right one, or
Okay. In Scala's parser combinators, those things do exist. Okay, this does exist. All right, so let's use these operators. What these operators do is they say that if you have a rich text codec of A and a rich text codec of B, you can combine them together into a rich text codec of AB. But if either A or B is unit, that is, if those rich text codecs produce something that is isomorphic to unit, so basically it's white space or something like white space where you can collapse all of that down to a single character or a single string literal, then like a keyword or whatnot, then you can always omit that unit from the resulting information produced by the parser. And this just allows you to simplify types. So the literal here, rich text codec of literal, that produces a rich text codec of unit, right? Can you hover over that and just verify?
uh,
Oh, that's string.
this is string.
Interesting. Yeah. So that's not necessary, I don't think. It's not necessary because, I mean, it isn't necessary to hold on to that string. So is there a dot unit or something that can sort of get rid of that string?
No,
Is it
I
as?
checked this before. So there's no dot unit, and as requires that it's already unit.
Okay. So I think we can add a new operator here that is is going to um, let's add a new operator. Let's call it canonicalize. And this is going to be used in cases like white space or keywords where it's going to be an operator, not a constructor. So
Yeah. So
alphabetically,
wait. Uh, so that's the rich text codec.
right before collect, maybe collect or fail.
Correct.
Yeah. Okay, so right after here, we'll add a new operator called canonicalize. ON, yeah, right.
Like
Which
this?
takes, yep, perfect. And this is going to take a a value, which is a constant, yeah, and maybe take it by name since that's sort of the convention here.
Yeah.
Not sure if we need to. And then this is going to return a rich text codec of unit. And what it's going to say is, even though we can parse many A's, in some sense, all of these A's are equivalent. And therefore, we can throw away all that information. And then if we have to go from structured back to the text, we're just going to use this A value. Okay, so it's basically saying we want to treat all these differing amounts of white space as equivalent, etc. So
You could actually also
yes, we're going to use
use
it
this
right
up here,
there.
right?
We're going to use it right there. But not there. We're going to use it after we do the OR. We can do
Yeah, okay.
canonicalize of what is it? Left of
Left n.
backslash n.
Yeah,
And we can use it above
here
there too,
too.
right?
Yeah.
We can use canonicalize of non-empty chunk of the space. All right, let's go back to canonicalize and implement this.
I did already.
Oh, you did? I didn't even see that. I wasn't.
I
Okay,
mean,
perfect. Yeah,
I
great.
pressed tab.
Copilot
I
did. All right.
verified it's correct.
Yes. Okay, good. All right. So we have the literal, and we're going to actually canonicalize that literal.
This,
Actually, let's add another constructor uh,
yeah, we
called
can,
literal unit.
yeah, which is just literal followed by canonicalized, right?
Yes, exactly. And what we're saying here is when we parse like a keyword or something like that, or a string literal, really the canonical representation of that string literal is just that string literal. There's only one thing to parse, so of course it would make sense to use that in the canonicalization. And actually, it looks like canonical or the other literal could be written in terms of this one, because if you look at the end of that loop, it just calls as lit, so it's going the other way. So it might be more efficient to copy paste the existing definition as literal unit, and then in literal we can just call literal unit as lit. See that?
Ah, okay, I understand.
Yeah, so just copy paste the entire body of literal.
But just one thing, let me check. I saw something here. What is this const? That's actually the
Oh,
thing we just implemented, right?
okay, great.
Okay,
Interesting. And
so
and there's a literal CI. What is CI? Case insensitive? Oh, that's not what we want.
yeah.
Okay, so yeah, I would copy paste the body of
So,
literal here.
but we go with const. Should I remove the canonicalize again?
Yes. I'm not sure what's a better name, const or canonicalize.
I think const is maybe more
Sure,
understandable for
more
somebody who is
accessible.
not so, yeah,
Yes.
into parsers.
Yes. Okay,
Uh,
so we have, yeah, copy paste that. You'll need curlies.
uh,
And then delete the dot as lit. And then up above for literal, you just call literal unit as lit. Right, so just a little housekeeping here, factoring out duplication. And now we can call literal unit just so we don't end up building information that we then end up throwing away. So a little more efficient. Okay, so back to our parser.
yes.
We're going to call literal unit.
Let me change this
Yeah,
to const
change canon.
first.
Yep, literal unit here.
Yeah.
And then what else do we have?
Not new
Not
line.
new line. Okay.
Since we have a new line, is there something like a not operator?
Well, there is a filter which we can use if we really want. Not sure that. Let's see how they define not new line. Oh, by the way, we're doing transform to unit right at the end. Is that right? So can't we just replace that
Sorry?
at the end of
So,
that line?
yes.
Yeah.
Uh, maybe, I don't
Or
know.
maybe the types will already be unit. Oh no, because we're going to have
Yeah,
the
yeah.
either. No, we won't. I think
Okay.
this will be fine the way it is without const, because not new line will be a rich text codec of unit.
And new
So
line
you can
is
delete
already
that. Yeah.
okay. Uh, where is the here's not any character except new line. And this is only backslash n. It's not uh
So this is
no
hexadecimal
hex. I don't know
um,
what this means.
10FFFF. That's a big number.
I think this is
It's 09 or it's 220. This is in hex 202, whatever that thing
yeah,
is. Okay, well, let's try to build this directly. Just do lazy val NL, or sorry, not NL,
yeah,
is equal to rich text codec dot filter, and then open up a code block maybe because there's going to be a few lines of code here. And we have some char C.
uh, sorry. Also,
Just
we
introduce a
need
parameter, lambda parameter.
yeah,
And then we want to do this comparison using hex. So we need to turn hexadecimal numbers
chars.
into not chars. I would actually do c.toInt.
Uh, like this.
Does Scala have hex literals? Copilot
I'm not
seems to think
sure.
so.
Let's yeah. Seems valid. I don't know if it's compatible with Scala 212. Maybe it's only 213 and 3.
Yeah.
That I
Well,
cannot
that can be a
tell.
to do. That can be a to do. So what we're saying here is that if it's 9, then we want to parse it. If it's 20, we want to parse it. Well, why did it generate that second line? It's subsumed by the third line. So delete that line.
Yeah,
If it's greater than 20 or
it's
20,
Copilot, not
sorry.
Autopilot.
Yes, and less than, okay, and true, otherwise false. That seems to be correct, right? Okay, assuming it's supported by Scala 213, then I think we're in business here and we have a working implementation of not new line. Now, there's a
Yeah.
little bit of a drawback here. Rich text codec, when you use this constructor filter, it's actually going to enumerate all possible characters and it's going to build a table. So there could be a small delay the first time this lazy val is accessed, but then it will be cached from that point onward and should be efficient after that.
And anyhow, this is not like hot pass code, right? Nobody is doing
True.
this in production on their server.
Yes. All right. So now we have documentation. We have line comment. Oh, no, we have documentation comment. We don't have line comment.
Yes.
So let's do line comment next. What does that look like? Those things don't exist.
Let's see. Who knows? Oh yeah, but repeat is yeah, okay. That doesn't exist. That's true.
Repeat 01 does not exist. So let me look at that and see if it actually got the intention right. So line comment is
I mean, this is obviously right. And then
it's trying to do optional here on something, I think.
I think it's an or of all of this, right? And then followed by not a new, multiple not new lines in a new line.
Yeah, I think it did the translation incorrectly. I think that asterisk notation means zero or more of, like it would in a
Yes.
regex.
Yeah, I think so too.
So what that means is it used the wrong translation. It should be just dot repeat because dot repeat gives us zero or more of. So of not
But
new line.
this
And that is skipping. It looks like it's skipping to me. So let's,
the
is that the same as
this
not new line?
I don't think so. Yeah, there's a slight difference.
There is a slight
Because here's
difference.
only two ors, right? And there are three.
Okay,
There's
so
like the
let's
space
make that
between
inline. Let's make
2e
that
and
inline.
3, 0.
Our first one will be literal unit, like it says. Then our second one, second rich text codec, has got to be a rich text codec dot filter. I would delete the whole thing. I don't think it's usable after that point. It's not going. It's just could be confusing. So this one's going to be rich text codec dot filter, and
Yeah,
then
that
let's
looks
check
good
this.
now.
That looks
That, that,
better.
yeah, that looks better.
20 to 2e, and then 30 to 10ff. Okay. So one of those, followed by delete that repeat non-empty. We don't want that. What we want here is delete that. We want a immediately following this single character needs to be not new line dot repeat. Right? You see that? So we have
Yeah.
this single character, and immediately following that is not new line dot repeat. But that repeat, we want to constant. And what is repeat going to give us? It's going to just give us just do const with empty chunk, const of chunk dot empty. After all, if we can parse zero or more not new lines, then we can always print zero new lines, not new lines. Okay, so uh, and then the combination of these two things is wrapped in square brackets. Do you see that on line 37 in the grammar?
Yeah.
So we need to wrap these two things. So no, wrap the filter and the const.
Filter. Yes.
Wrap those two things in dot optional or whatever. Is there a dot optional?
But it wants a char.
That's because we're parsing a char. Because we have to have, well, why does it want that?
When, like for writing, when you didn't read anything of it.
Yeah, I just wonder why it wouldn't always generate none. Go see, yes, optional has a default.
Yeah.
So basically A is mapped to sum of A, and then the option is turned into, okay, so we have to, this one is saying that we have to, I'm trying to think if this makes sense. Does this make sense?
I think we could just return. Uh, space, because space
Sure.
is x20, right?
Yeah, it has to be some character in that set, and space is acceptable. And all of this gives us an option, right?
Yeah,
See what
like
the type
here
is of line comment?
yeah, increment is which
It's an
text
option
coded
of a
option
char.
of
I would
char.
const this to unit or none, sorry. Const it to unit by specifying none. Yeah.
Yeah.
Okay. So now we're saying this line comment, basically, if you generate this, I think you're always going to get, um, if you pretty print a line comment that you parse, you're always going to get back just an empty line comment.
Yeah, because we don't save the value of the
Oh, we forgot one thing, which is the new line character.
yeah.
So immediately following the optional, we've got a new line character. So you need to go inside the parentheses, inside. That's going to be inside. It's going to be right after repeat const of chunk empty.
Mm,
Wait, is that right?
no, it's not right because it's not inside the brackets, right? So it's not
Yeah, you're
optional.
right. Yeah, it's going to be, yeah,
So it was right as it was before, not like
yeah.
this.
So that's right. And then new line produces unit, right? So we can use that operator on it.
Yeah, new line produces
Okay.
unit.
All right. So now we've got the literal slash slash, something that's not a slash, followed by new line. One or more things that are not a slash, followed by new line.
Yeah.
One or more optional things that are not a new line, followed by. Basically, if there is something between the slash slash and the new line, then that thing can't be a slash. At least the first thing can't be a slash. There has to be something that's not a slash, and then there can be whatever there you want except a new line. That makes
So
sense.
the last thing that we have now left for WS is comma, and I guess that's just this.
Yeah. Yep. And then literal unit, actually.
Yes. And then
Okay.
also the return type here should be unit, right?
Yes.
Yeah, it's a lot of
Whoa.
it's the wrong operator, right? It should be the tilde one.
No, we want or. But here's the
So
thing.
okay, but
It,
but ignoring it.
let's uh let's insert a few variations of or in
Yeah.
the case that one side or the other is unit,
Yes.
right? So I would do copy paste just that signature line,
Yep.
and then for this one, don't have a type parameter b. Actually, call it tilde pipe tilde. And have rich text codec of unit and have implicit evidence that A
Is
is a unit.
unit. Yeah.
And this will return a rich text codec of unit. Okay, so how we do this is, first off, is there
Does
a
it exist
method?
already? Is it this one?
No,
No. Okay. It's
this is
just
sequence. We need alternation. So it's going to be self or that. But
const
also
unit.
we need to recognize self as producing unit because we've only accepted implicit evidence of that.
Yes.
So look for one of these other operators like the one below that accepts implicit. I think it's as
Mhm.
actually. We need as self as
This
unit.
type, this one.
Yes. No, the one immediately below you. You can see its signature barely. It's just as. So what you do is as, and you feed it a literal unit value, and that basically gets rid of the a type. No, a unit is empty
Yeah,
parens.
yeah, yeah.
And then we have either units. Okay, that's good.
And
And
then we
then
can say const unit, right?
we could do, yes, const left of unit or right of unit, doesn't matter, but probably
Uh,
left of unit.
Does merge exist?
No.
Yeah.
Does
No,
it?
it's exists. It exists, and it does exactly what we want.
Perfect. Okay, now let's add two variations, probably just one, and then Copilot will figure out the rest. Final def.
This one.
So this one would be saying keep the one on the. I'm not sure. Do I agree with that? I think this one should be keep the one on the left-hand side. So I think this one should not take a type parameter A or B, sorry. It should not take type parameter B, and it should expect that to be unit. And it should not expect any evidence. And what it's going to do is if you have this one that produces an A and this other one that produces a unit, and you're ORing them together,
Then get back A.
yeah. Oh, but is that even possible? That's not possible, is it? Because,
Why?
well, let's try it. So we do self
So if it's not unit, right?
or that, or no, yeah, or that, yep. And then we have to do transform on that. And then we have,
Ah, yeah. No, I see what you mean. You because if it's that, then what is the A output, right?
let's see
You
if we can
cannot,
write it. I don't think we can, right? Because
yeah,
we,
because you cannot go from unit to A. Like if you have now a unit, then how do you get an A out of it,
well,
right?
what if we always go to the left-hand side? So let's just try it. See what types we need. We need, the first one is easy, right? Because it's just insert the type explicitly. We need to go from either a unit to unit. So that's easy. We just return unit. Constant.
So it's just this, right?
Oh no, we need to go to A, right? Do we
We
need to go
need
to
to
A?
go to which one is the
We're transforming to type A.
to type A?
So
Yes, yes, yes. You're
so
right.
that means we need to produce an A. So we can't do that. We can't go
Yeah,
from
that's
either.
that's that's what I meant before, right? Like if
All right, so delete this method.
yeah,
We can't do it. And that also implies we can't do the other side. So,
yeah.
but that's okay. We don't need it. All we need is the operator we wrote
You,
because in our
you
case, all of these happen to be unit.
yeah, you could only do it in a way that you hand over a default and then say
But then
when
you can already do that by calling const. So first
yeah.
you call const and then you call this operator. All right, so let's use this operator. Yeah, yeah, use it here for everyone. Every one of these branches is going to be this kind that basically doesn't care. And what we're saying here, the high level way to think about this, there's a lot of details here and a lot of types, but the high level way to think about this is that it doesn't matter what you parse as white space, whether it's a space or new line or comment or comma or whatever, it doesn't matter. Ultimately, when you have that structured information, which is literally a unit value, we're always going to go back to the same white space character, which it might be empty for all I know. We could figure that out by looking through here, but basically we're saying it doesn't matter how much white space is in the original document. Once you parse that and then you try to print it again, you always go back to that same white space character or empty, whatever it is.
Oh,
Insert
there's a
parentheses
char
if it has
somewhere.
trouble.
I
Oh,
know
there's a
there's a
char?
char. Here in comment is the char.
Ah, that's not good. So hover over all those types.
Yeah, it's
Is
this
that
one here.
documentation comment?
Yeah,
Okay, so we're producing a char here.
the literal. Oh no, the literal unit is not. Then must be one of the others. Here, this one. Not new line. Uses char.
Is that producing a char?
Yes, here we have to
Constant away.
const.
Just do a space character. After all, a space character is not a new line. So we're saying all of these not new lines, when we
Yeah,
print them out, we're just going to print out a single space character. Okay, we're still not there because we somehow got either unique
because
unit from
we
something.
need this operator here
Ah,
too.
yes.
Yeah,
Are we in business?
think so.
All right, fantastic. So we have managed to finish in our hour. We've managed to finish exactly one of these non-terminals. But
Uh,
I think the good thing is we're basically teaching Copilot how to do these
yeah,
with these examples. So they're going to come faster and faster. The more of these we do, the faster they're going to come. And right now, hopefully, with my help, it's become clear how we build these things using rich text
yeah,
codec. We added some new operators to rich text codec to make things easier, and now it's becoming increasingly a straightforward process of translating this grammar into rich text codec constructors and operators. Is there anything really challenging here that's different than everything else we've done? It just looks like more of the same to me.
I think so. I mean, we can uh, take a brief look over that one, right? So yes, I don't know. This is literals. I thought first this is like some option with an option inside or something like this, but no, that's just literals.
Yeah.
Also literal, or again this optional thingy.
Yeah,
Did
it's all
it?
more of the same. So
Yeah,
I think the rest of this should be pretty straightforward now that we've established a pattern.
yeah. Probably more challenging is to adjust uh, the ADT because I'm pretty sure since it's a lot of structure, right?
Yes.
It's not a huge syntax, but it's also not a small one. So I'm
Yes.
sure I will not have the ADT right and have to adjust and probably I do one thing and then I realize, oh no, it's still not 100% right and adjust again
Yeah.
what I already adjusted. But
Yes.
yeah, I mean that's coding, right?
Yes.
You
All
understand
right.
the
Well, feel free to book another session if you like.
yeah.
All right. Thanks,
Yeah.
Nabil. It was great having you on here. I think what we did in this session is we took a look at what Smithy is and why people would want to use it, and also why a library like ZOHTTP might want to parse Smithy, mainly so it can generate these type-safe endpoint definitions that all a developer has to do is plug in with their implementation. And then
Yeah.
we also took a look at sort of how, at a low level, all of these different languages and text formats and whatnot specify their structure. And if they're text-based, they end up using some variation of BNF. This one uses a BNF, which I'm not super familiar with, but it's just basically some sort of augmented or extended Bauer-Nakas form notation. And then we've also taken a look at how you can use parser libraries. In this case, one that's actually built into ZO HTTP, and one that can both parse as well as print. So it can go both ways. Those things are called invertible parsers. How we can use this library to achieve a translation of the BNF grammar into something that's actually executable. And we didn't actually take a look at this in this session, but there is like a parse method on rich text codec that you can use to feed it some text and get back that structured information as a value of type A. So we're probably, I would say probably 2 hours away from something that can parse all of Smithy and then also print it out,
Yeah.
excluding maybe whatever troubles we would run into in the data structure. But I think we're about 2 hours away from that. So yeah, feel free to book another session. It was great having you on. Great having you back after
Sure.
all this time, and look
But,
forward to our next collaboration together.
but by the way, one remark for the ones watching. So also, of course, this means since we can print the stuff, we could probably, based on this, do the other way around. So you define like an endpoint in the HTTP and you generate out of it SMISI. This should be also possible at some point in the future. But what I'm working on right now is the other direction, since I guess it's the more common one, especially with
Spec
SMISI.
first versus code first. Yeah.
Yeah.
People who are into Smithy are very much spec first kind of
Yes.
people.
But I also thought about this. When you write the endpoint definitions first, right? Is it
Yeah.
not actually also spec first? Just because you write Scala
It's
code
just in
doesn't mean it's not
Scala.
spec. Yeah, exactly, right? This is
Try to
also this is
convince that to management.
yeah,
Yeah, no. I'm a code first person because codes have compilers and it's less learning new languages. But I understand when you have many different teams and they all need to interact with
yeah.
the same interface in different languages, I understand the value of spec first as well.
Uh,
Anyway, great having you on, Nabil. And
yeah, sure.
I look forward to our next collaboration.
But by the way, if anybody is interested in the work I'm doing, 987 Nabil at X, GitHub, and Twitch.
Yes, please follow Nabil on X and Twitch. All right, see you later, everyone. Bye
Yeah,
bye.
bye.